Now let's solve this free response question from the projectile motion. Two identical spheres are released from the device at time t is equal to 0 from the same height. So the height is same in both the cases as shown in the figure. Sphere A has no initial velocity. So the initial velocity for this case is 0. Whereas sphere B is given a initial horizontal velocity. Initial horizontal velocity ux naught is equal to v naught in this case, and travels the horizontal distance d before reaching the ground. The sphere reaches the ground at tf at the same time. So both the spheres reaches at the ground in the same time tf, even though sphere B has more distance to cover before landing. Air resistance is negligible, means ax acceleration in x direction is 0. The dots represent the sphere A and sphere B. We have to draw the free body diagram showing and labeling the forces exerted on sphere at the time t f upon 2. So what are the forces acting on ball A and ball B? The sphere, the force acting on it is the mg force, which is bringing the ball in the downward direction. What are the forces acting on sphere B? Don't get confused. Just separate axis components and y axis component and treat them differently. So what are the forces acting on the y direction? Obviously the mg. And what are the forces acting in the x direction? So the acceleration is 0 in the x direction, means there is no force acting in x direction. Okay. And this is the free body diagram. Both the forces in sphere A and sphere B, both having only one component, that is in the y direction, that is your mg force acting on both the balls. Okay. The next part of the question: on the axis below, sketch and labels of a graph of a horizontal component of a velocity of sphere A and of sphere B as a function of time. So we have to draw the graph. We have to tell the horizontal component of velocity of sphere A and sphere B as a function of time. So for sphere A, because it is only pure vertical motion, there is like uh, in x direction there is no velocity. So for A, this is the graph. It is 0. And for the B, what is the horizontal velocity? Is it changing with the time? When the motion is happening like this is a projectile motion and there is no acceleration in x direction. So what is the velocity in x direction? It would be equal to the initial velocity in x direction, or I can say it would be equal to v naught only. So if I, because the scale where the value is not given, so I can write it as v naught, and this is also constant line because it is not changing with time. Okay, got my point? So this is line for the B, because only we have to draw the horizontal component, that's why it is a straight line. Okay. Let's move to the next part. C part. In a clear coherent paragraph length response, explain why the spheres reach the ground at the same time even though they travel different distances. Include your reference to part A and B. For the case A, for the sphere A, this initial y velocity, so this is the h distance covered, and let's see what is the time taken in this case. So we know from the second equation, we know s is equal to u y into t plus half a y into t square. Okay, we try to find the time. So what is the initial velocity? Initial velocity is 0, right? U naught is 0. It was not given any initial velocity, so it is 0. Now this s is what? This vertical distance, because the vertical distance is in this direction, so I can write negative of h is equal to half. So acceleration in y direction, that is negative g into t square. So negative negative got cancelled, and the time taken to for the ball to reach the ground is equal to 2h upon g root of it, the square root of it. This is the time taken to for the ball A to reach the ground. Now let's talk about the sphere B. Sphere B. In sphere B, it is given the horizontal component V naught. So it is V naught is it is ux initially, right? But is it given any vertical component? So this is h, and it also covered the distance d, and this is the motion, right? So initial y direction velocity is equal to 0 in this case. So I am applying equation second kinematic equation in the y direction. So I can apply s is equal to uy into t plus half ay into t square. So the same equation that we use in the for the sphere A, and since you know y initial velocity is 0, that's why this term would be 0. Again the s is the vertical height, okay, so it would be negative h is equal to half of minus g into t square. So same equation is deducted from this. So what we infer from this, that g is in like time is equal to the, it depends only on the vertical component, it has to do nothing with the horizontal component. Okay. Thanks for watching. If you like the video, then please like it and subscribe the channel. We will bring more problems along with the solution. So if you have any query, then you can WhatsApp me. If you want a private tuition from me, then you can scan this or send me an email on forcetra.physicss@gmail.com. See you in the next video.